Curiosity stumbles upon an ancient stream bed, takes some spooky images during the night, and finds bright particles on the Martian surface. August 6, 2012. The Mars Reconnaissance Orbiter happens to be in the right place at the right time to capture this incredible image of the Curiosity rover parachuting onto the surface of Mars. After a nerve-wracking but successful landing, Curiosity opens its eyes. It will eventually start to climb the mountain in the distance, which is informally known as Mount Sharp. For now, however, the rover will drive away from Mount Sharp towards an interesting region known as Glenal. Just 13 Martian days into the mission, or Sol 13, Curiosity examines a site that was blasted by the engines of its descent stage. Nicknamed Goldburn, scour these sedimentary rocks, are thought to have been laid down by running water in the ancient past and uncovered by the descent stage as it blasted away the surface dust. On PSAL 16, Curiosity takes a close look at the layers which form the base of Mount Sharp, with scientists theorizing that these layers could be another clue of a watery past. On Sol 27, Curiosity comes across a site which again could be linked to running water. This image shows what is known as a sedimentary conglomerate, a geological formation that is created by streams or rivers here on Earth. The engineers at NASA check the health of Curiosity's wheels. They look to be holding up pretty well. So far on PSAL 39, the rover comes across yet more evidence of a Martian stream. This is a piece of exposed bedrock, made up of small segments cemented together. This is likely evidence of ancient water due to the rounded elements of the bedrock itself, as well as the round rocks and pebbles surrounding it. It's possible these rounded rocks were transported and deposited here by running water. If finding 3 sites, likely formed by running water, wasn't enough evidence, just look at how they are arranged. The yellow arrows at each site depict the direction of the ancient stream, while this map shows the route the rover has taken. So far, Curiosity turns around to once again taking the site of the mighty Mount Sharp. In this incredible mosaic, climbing the mountain will be hard, but worth it in the end. Curiosity comes across an interesting pyramid-shaped rock and decides it's a good time to test out its onboard laser. In this image, the dots are where Curiosity trained its laser, and the results are unlike anything yet seen on Mars. The rock has a mineral diversity down to the finest scales, and is very similar to a rare but widespread rock type found on Earth. On the road to Glen Eogia, a site known as Rock Nest is selected for the first use of Curiosity scoop. The patch of sand downhill from the cluster of dark rocks should make for a great scoop sample. At the site, the rover comes across an interesting rock. It's not clear what has caused the thin cavities present in the rock. On Sol 61, Curiosity makes its first scoop. Darker colored sand is exposed just beneath the surface. The sample will now be shaken and put through a filter. This series of images shows the shaking operation. This makes sure that the sample scoop is not overflowing with material and allows the scoop to be sealed shut. This image shows the filter after the shaking operation. Any particles too big to pass through this filter are transferred back to the scoop for a visual inspection. Those larger particles can be seen here. This first sample will not be fully processed, as its presence in the scoop helps to further decontaminate all the surfaces coming into direct contact with future samples. On Sol 65, the team at NASA spots an interesting piece of debris on the Martian surface just next to the rover. This close-up confirms it is likely to be from the spacecraft, possibly as a result of the landing. It is likely a benign piece of plastic or shrink tube, left over from a terminated piece of wire. As Curiosity takes its second scoop, a bright particle can be seen in the sample hole. Given that spacecraft debris has been identified in the area, the team at NASA orders the rover to also discard the second sample. if any of these bright particles are from spacecraft and are subsequently fed into the internal sampling unit, the rover could become contaminated with bacteria from Earth. However, upon further inspection and analysis, more bright particles are spotted on the ground, and the team now believes these are native to the Martian soil. It is likely these bright particles are made up of silica or some other naturally occurring mineral. With this knowledge, the rover goes ahead and takes its third scoop, which is fully processed. The result of the soil sample shows that about 2% of the material collected is made up of water. The rover exposes the sample to heat. Carbon dioxide, oxygen, and sulfur compounds are released. To celebrate, the rover takes a little break from sampling and captures this stunning panorama of the rock nest area. Curiosity will continue on to Glenal. Sol 120. The rover comes across a site nicknamed Shayla. The Shayla outcrop is dramatically layered, once again signaling the presence of water in the ancient past. This part in particular, known as Sheepbed locality, shows well-defined veins filled with a whitish material, likely to be calcium sulfate. The rover reaches a wider area known as Yellowknife Bay and takes a look around. In this annotated image, the white arrows represent mineral veins, and the black arrows represent mineral concretions. Both veins and concretions are strong indicators of mineral precipitation. From water, a target is chosen for the first use of Curiosity's drill, a drilling site known as John Klein. This flat, hard bedrock should provide an ideal testing ground. As the engineers at NASA prepare for the first drill, Curiosity spots a small broken rock nicknamed Tintina. Curiosity deploys its MARS cam to perform a spectra analysis and produces a mineral hydration map. The results show the inside of the rock is much more hydrated than the outside. The team orders Curiosity to pull an all-nighter. These are the first nighttime images from the surface of Mars. The team wants to see what the rocks look like under UV lighting, to see if any fluorescent minerals are present. Unfortunately, this image taken under UV lighting doesn't show much evidence for fluorescent minerals. If they were present, we would see bright red, blue or orange areas. On Sol 174, Curiosity breaks a rock in half by driving over it. A happy accident. Curiosity's clumsiness reveals a very bright substance within the rock. This is probably caused by the presence of silica, commonly found on Mars. Curiosity takes a selfie before its big drill test at the John Klein site. The drilling goes ahead and is a great success. The drill sample is transferred to the scoop, which will feed the sample into Curiosity's internal sampling system. On Sol 100, Curiosity stops responding to commands. Engineers fear Curiosity is stuck in a boot loop, which will cause the rover to drain its battery and be unable to function. Luckily, Curiosity has two computers on board for such a problem: Side A and Side B, or pilot and CO pilot. The rover is programmed to switch to the CO pilot automatically if the pilot malfunctions. However, the pilot has other plans and does not cede control to the CO pilot. The engineers are worried that the pilot could shut off the radio at any moment, and they would never hear from the rover again. They decide to take a risky move and shut down the pilot, hoping that the CO pilot will then step in and take over. After shutting down the pilot, the team waits to hear a signal from the CO pilot, which should happen right away. 1 minute passes, no signal. 4 minutes pass, still no signal. Then finally, the signal comes in, and it's clear that the CO pilot is now in charge. Curiosity can breathe a sigh of relief and continue with operations. Now that the rover has switched over to the B side, the team must check all the systems once again. Now that everything is working as intended, Curiosity takes a long drive